and then move over to Isabella Wiedmann and Marcello Grassi, and they talk about accelerometric gait analysis devices in children. Will they accept it? A topic that was alluded to by Jörn earlier this morning.
Thank you very much. Today I would like to show you the results of the AVAPET study. We do know that accelerometric devices are very, very good investigated in the adult population, but we don't know if that could be used in children. Usually children has very often problems to express themselves regarding of the quality of movement or the activity level. For this reason, it is very important to explore whether pediatric patients and the parents would tolerate measurements with a wearable sensor, which is attached around the waist. Our main intention was to evaluate if children would accept the wearable sensor attached around the waist, and our second outcome was to compare gait speed under supervised testing, which means laboratory condition with real-world gait speed. What is cerebral palsy? Cerebral palsy is defined by a group of permanent disorders of the development of movement and posture. Usually it is attributed to non-progressive disturbances of the developing fetal or infant brain, and often comes along with disturbances of sensation, perception, cognition, communication, behavior, or as well by epilepsy and musculoskeletal problems. We collected some baseline data from two groups, which is a CP group, a group with cerebral palsy, with the gross motor function classification scale from 1 and 2, which means that they are able to walk independently. And we had a healthy control group. We had a control, not randomized monocentric study, which took place from March 2018 to October in Cologne. We collected the baseline data from a 1-minute walking test, which is the laboratory condition. And then we handed out the device to our participants for 1 week together with a questionnaire. Here on the right side, you can see a little girl wearing that kind of device attached around the waist. We measured our acceptance via wearing time and the questionnaire, and the validity under laboratory conditions we measured with a mobile perambulator, which could be seen on the right here. We used that as a gold standard. Our statistical methods had been an intention to treat analysis with singular imputation for the missing values, and the wearing time was tested with the unpaired t-test. Pearson's analysis had been conducted between gait speed and of the active belt and the gold standard in the 1-minute walking test. And a visual comparison of the 1-minute walking test. The mean had been conducted between the walking speed calculation. We compared the walking speed of the 1-minute walking test and the home measurement walking speed with the Bland-Altman. And as well, we used the Bland-Altman plot and linear mixed effects model. So we had identified 88 subjects for eligibility. From our 50 cerebral palsy participants, 20 participants had been excluded because they refused or they had not met the inclusion criteria. The healthy control group had been collected via an email recruitment, and they had been collected from our staff personnel. And so we are not able to say how many had refused or had not been interested in participate. From our data values, we were able to use 54 sets, and the others had been replaced by the intention to treat analysis. Now we will show you the baseline data. We had the age in total, which was 7.8 years. You can see probably that in the control group, the age was a little bit higher than in the control group. If we compare that with the body mass index, we find in the CP group a little bit lower body mass index than in the control group. Yeah, can we go to the next slide, please? Here you can see the acceptance. The acceptance was measured via the questionnaire, and these are the results of the questionnaire. We found in the restriction scale almost 90% per group regarding restriction. We have a slight difference of 3%. Same is for the comfort scale. There we have found 80% with positive score, and as well a slight restriction or slight difference of 3%. As a secondary tool to understand the acceptance of the active belt was to use the daily wearing time. And here both groups have shown a good adherence with an average daily wearing time of almost 10 hours plus minus couple of minutes. The questionnaire was and the wearing time was very high rated. And so we conclude that in general, the acceptance was very high in this population, in both cerebral palsy group and control group. With further analysis, we would like to check if we could retrieve gait parameters for the active belt, although the algorithm had been developed for the adult population. We were interested in the walking speed differences between the control group and the cerebral palsy group. You can see that in figure A, that the control group had a higher walking speed than the CP group, and the difference was 0.3 meters per second, which was also reflected in the 1-week home measurement, which is in figure B. The control group had a high walking speed in general than the CP group. Maybe we can go to the next slide. Well, it is to discuss. We had a little bit more problems to attract probers for this study participation than to make them wearing the active belt. And in the past, for the wearing time for adults, 10 hours had been regarded as a minimum. But as children sleep much more than adult population, we estimate that the average wearing time from 9.9 and 10.8 hours in CP is considered as representative. Otherwise, the walking speed algorithm had not been validated for the pediatric population. So we would need to confirm or to support the confirmation of the results. As well, we have some inter-individual variation in the 1-week home measurement and the 1-week 1-minute walking test, but that's only a slight one. Well, the real-world gait speed shows that is pretty complementary to the laboratory assessments. And in general, it is very difficult logistically to have a high quality in general. Yeah. Maybe we can go to the discussion, conclusion. General, we had good acceptance in terms of wearing time and reported comfort. We had no significant differences in the reported restriction of activity of daily living and comfort of wearing in both groups, which means that is comparable in healthy and CP children. Wearable accelerometric devices can be used in the pediatric population, and based on the discrepancy from the data from the Actable, the questionnaire in several cases where we presume that the accelerometric devices will prove very, very helpful to monitor the behavior or the behaving of the children in real world. Yeah, thank you for your attention.
Isabella, thank you very much for your talk, and also Marcello, and also, but not just for the talk, but also for the hard work you've been doing in this very special population. And in a sense, well, what is extreme ends for physiology, for example, studying hibernating bears, is in a sense extreme ends in clinical research. If you go to the extreme ends of the spectrum, very, very old people, or very young people. And that is really something one should not forget. This is really a remarkable extra effort, because you have to deal with the parents, ethics, and then all this stuff. Yeah, and also what you said, the problem with getting gold standard data, just for the other people to understand what this means, you would need probably a team of 3 people on site, doing the gold standard recording with a camera, with a measurement wheel, doing the electronics, the data management, and then subsequently have a basis for actually doing supervised algorithm training, and then validate this stuff. And that is, given the boundary conditions with these children, the parents, really hard. Yeah, but okay. Now, and on the other hand, I think it's important because very interesting ideas can be generated if you go to these extreme ends, that then will be of benefit for a broader population as well. In particular, comfort and wear time and wearability. Okay, now are there any other questions or comments on this talk? So I don't see any hands going up.